Hello, my name is Keshwani. It's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 484. 484. And today is our lesson number 28, day number 28. Let's take a look at it. The very first one they give us is a little graph here, which looks something like this. And the question simply is, which of the following graph is the reflection of the graph above about the x-axis? Well, reflection of the graph about the x-axis simply means they were looking for mirror image of it. We're looking for mirror image of it. In other words, we're going to pick it up and we're going to fold it this way. So instead of looking at the answer choice and then trying to figure out what's going on there, the best thing to do here is to flip it. Pick it up and flip it. If I flip it, if you were to flip it, it's going to look like this. This top part here is going to end up in the bottom here, and this bottom part here is going to end up on the top here, and this line going up is going to end up here. That's it. That's your mirror image. And the one that matches this pattern, is answer choice A. That's all. There's not much there. There's not much there to do. There is not much of a solution that I can show you. That's it. We're done with this one. The answer is A. Don't analyze it to death. Do you understand? Just pick it up and flip it along the x-axis. Let's do the next one, number 10. Number 10 is a tricky one. It's a level 3 question. As you know by now, the college board likes to divide up a scale of difficulty into 5 grades, level 1 through 5. This is a level 3. We are told that x plus y whole squared equals 100, and we are also told that x minus y whole squared equals 16. The question is, how much is the product of x and y? How much is the product of x and y? Well, there are two ways you can go about it. One way is to just simple trial and error until you find something that works. I'm not sure if that's a good idea. We have to have 100 here, which means their sum has to be 10. Their sum is going to be 10 because 10 squared is 100. And there aren't too many possibilities. It cannot be 1 and 9, because 1 and 9 would be 9 minus 1 would be 8, and that 8 squared is not 16. They have to be very close to each other. They can be 9 and 1. They can be 8 and 2, because the difference is 6, and 6 squared will be 36. They can be 7 and 3. Can they be 7 and 3? 7 and 3, 7 plus 3 is 10, and the difference is 4. Oh, there you go, we found it. By golly, this was actually much simpler than I thought. That's it. 9 and, okay, let me start again. 9 and 1, we are told that x plus y squared equals 100, which of course is the same as 10 squared. And we also told that their difference has to equal 16. And since x plus y has to be 10, because that's what it is, we started out with 9 and 1. 9 and 1 right away we knew was not going to work, because 9 minus 1 is 8, and 8 squared is not 16. Here we'll end up with 9 minus 1, 8 squared, which of course is not 16. Not only is it not 16, but this is a very large number, which means that tells us they have to be closer to each other. Next we tried 8 and 2. It didn't take long at all. 8 and 2, difference would be 6, and 6 squared is not 36. 6 squared is not 16. Then we tried 7 and 3. 7 plus 3 squared is 100, and 7 minus 3, which is a 4 squared, which is a 16. It works. The numbers that x and y are 7 and 3, just by pure trial and error, we found it on the third try. 7 and 3, that means the answer is 21. That's it. Well, this was quite unreal. This was amazing. I'm very surprised, because what I have in my notes here is a very traditional, very algebraic very classical way of doing the problem, which I'm going to show you in a second. So apparently I did not see the quick way here before. Most of the time in algebra questions on the SAT, there are two ways you can go about it. One is what I call the traditional way, the classical way, the orthodox way, the conventional way, the geeky way, the nerdy way, the academic way, the algebraic way. And the other one is what I call the quick and dirty way. For some strange reason, I did not see the quick and dirty way until I just started doing it. I just said, let me try it. What the hell? It can't be that bad. And it wasn't that bad. On the third try, we found it. Now let's do the same problem. I need my both hands to finish my sentence. Let's do the same problem the proper way. Not that I would recommend doing it the proper way in the exam, because nobody's going to give you extra credit for it. It takes too long, and there are too many chances of making a mistake. This is fine. This is beautiful. But let's do the algebraic way anyway, shall we? Algebraic way is not that simple. But then again, algebraic way is hardly ever simple. X plus y whole squared, we have to understand the same as x squared plus 2xy plus y squared. Similarly, x minus y whole squared, we know, is x squared minus 2xy plus y squared. That we do have to know. That we do have to know. Now let's add up the two equations. Remember, this we are told is equal to 100. This we are told is equal to 16. Let's add up the two equations. When we add them up, we find 2x squared here, x squared and x squared, we get 2x squared. Here we have a positive 2x and here we have a negative 2x. They're going to cancel out. And here we're going to end up with 2y squared. And that equals 100 plus 16, 116. So we have 2x squared plus 2y squared equals 116. Let's divide the entire equation by 2 and we find that x squared plus y squared equals half of that. How many 2's in 11? 11 has 5 2's. The remaining one goes and joins the 6, becomes 16, and 16 has 8 2's. So that's the equation we need. X squared plus y squared equals 58. We're going to make use of that equation in one of these two equations. Let's finish it up here. So now we know that x squared plus y squared plus 2xy, right here, I'm using this equation right here. This is the equation you're using now. X squared plus 2xy plus y squared equals 100. This is what I'm using. Equals 100. We just found that x squared plus y squared is 58. So this part is 58. So it's 2xy 58 plus 2xy equals 100, which means 2xy equals 100 minus 58. 100 minus 60 is 40, so it's 42. And therefore x times y is 21. Just like we found before, purely by trial and error. Oh, we have one more to go. Sorry, I thought we were done. We have one more to go. I'll give you a chance to absorb this thing for a second. This turned out to be much simpler than I expected it to be, because I was doing it the algebraic way. There was a quicker way. Let's do number 11. That's it, we are done. In number 11, we are told that -1 is less than or equal to 4x minus 5. What we have to understand about inequality is that when you're dealing with inequalities, when you're trying to solve for a variable in an inequality as opposed to an equation, that is no different than solving an equation. Anything that you can do while you're solving an equation, you're allowed to do that, while you're allowed to do all of those things while you're dealing with inequality. The only exception is this. For example here, 3 is less than 5. Would you agree to it? 3 is less than 5. Yes. You would also agree that 3 times 4 is less than 5 times 4. Of course. So as long as you multiply both sides by a positive number, you're fine. But what happens if you were to multiply both sides by a negative number? Now -4 times 3 is -12, and 5 times -4 is -20, and -12 is no longer less than negative 20, negative 12 is more than negative 12 is more than negative 20. It's no longer less than that. So the only thing that we have to keep in mind is if we multiply or divide an inequality by a negative number, then the direction of the inequality needs to be changed. So I'm going to say it one more time. If we multiply or divide an inequality by a negative number, then the direction of the inequality needs to be changed. Let's look at the scenario of division. Everybody would agree that 10 is more than 8, of course. If we would divide both sides by 2, 10 divided by 2 is still more than 8 divided by 2, because 5 is more than 4, of course. But what if we were to multiply divided by negative 2? If we were to divide both sides of the inequality by negative 2, then 10 divided by negative 2 is negative 5, 8 divided by negative 2 is negative 4, and negative 5 is no longer greater than negative 4. Negative 5 is in fact less than negative 4. This is no longer true. The direction of the inequality needs to be switched. That's the only thing we are going to have to keep in mind when we're dealing with this inequality. If we come upon a situation where we need to multiply or divide both sides of the inequality by a negative number. I do not know if we will come across it, but if we do, this is the only rule that we have to keep in mind. Everything else is the exact same thing as you would solve an ordinary equation. No difference. Let's do it. Let's add 5 to both sides. Adding and subtracting a number doesn't do anything. Only when you're multiplying or dividing by a negative number. So negative 1 and a positive 5 is a positive 4. It's less than or equal to, here this drops out. It's less than or equal to 4x. Let's divide both sides by 4. Let's divide both sides by 4. And what we find is that 1 is less than or equal to x, which is same as saying that x is greater than or equal to 1. These are the exact same thing. They're the exact same thing. Question is, how do we plot this thing? X is more than or equal to 1. It's very simple. There is our number line, there is our 0, there is our 1, and because it has an equality sign in it, because it has an equality greater than or equal to, we have to include this point, and we include this thing by closing a dot. All the way from here, all the way to infinity. Let me use a different color. So here's your dot here, and here's a negative 1. So starting with positive 1 and going in the right hand side direction all the way to infinity, forever and ever. Amen. And that's answer choice A. That's it. That's your answer choice A. And that's all there is. We're done. I will see you tomorrow. Okay? Bye now.